Okay, for today's video, we're picking up where we left off with yesterday's video. So we're on the bottom of page 1 of our Chapter 9 notes packet. We have 3 problems to go through. We're going to be solving the right triangles, and to solve the right triangle means to find all missing side lengths and angle measures. It says, using the diagram in the given measurements, we have numbers 15, 16, and 17. And I just want to note that we are going to find the missing side lengths and angle measures. And we are going to round to the nearest tenth. Just want to add that, round to nearest tenth. Now, before we begin with number 15, if we look at a right triangle, all right, so we have this right triangle ABC, and the vertices of a triangle, it's standard that they are labeled using uppercase letters, right? We have uppercase A, uppercase B, uppercase C. Our right angle in this case is angle C. And the side opposite the angle is labeled with the corresponding lowercase letter. So here, opposite angle A, the side length is noted or denoted as lowercase a. The side opposite angle B is denoted by lowercase b, and the side opposite angle C is denoted by lowercase c. So that's standard. Now for number 15, we have that A is 14 degrees. So angle A is 14 degrees. So I'll put 14 degrees in for angle A. And lowercase a is 6. So the side opposite angle A has a length of 6. And we're going to use our trig functions to find the remaining two sides, lowercase b and lowercase c. And we'll just use that the angles of a triangle add up to 180, or the two acute angles of a right triangle are complementary, right? They add to 90. So first, if we wanted to solve this, find angle B, well, angle B would equal 90 minus 14 degrees. And 90 minus 14 is 76 degrees. Right? I'm not going to put 76 degrees in for angle B because I'm only going to work with the angle measure that was given to us, and that was angle A. So now in relation to angle A, let's first note the hypotenuse. The hypotenuse of this right triangle is lowercase c. Now, in relation to angle A, 6 is the length of the side opposite the angle, and lowercase b represents the side adjacent. So let's label this. So we have our opposite, adjacent, and our hypotenuse. And I'm just going to go about this in alphabetical order. All right, so next we know the length of side A. Now we want to find the length of side B. Well, what do we have? We have the side opposite, and what are we trying to find? We're trying to find the length of the side adjacent. This is what we're trying to find. Opposite, adjacent, what trig function relates opposite and adjacent? That would be TOA, tangent, right? Tangent is equal to opposite over adjacent. So we say the tangent of angle A, and angle A is 14 degrees, so we put in the angle measure. Tangent of 14 degrees is equal to 6 over B. Now if I treat this as a proportion and just write tan 14 over 1 and cross multiply, we have B times tangent 14 degrees is equal to 6. We want to solve B for itself. So we will divide, right now we have B times tan 14. What undoes multiplication is division, so we divide both sides by tangent 14. So b equals 6 divided by tangent 14 degrees. Now that we have our variable b by itself, now go to the calculator. Again, make sure that you are in degree mode, all right? And 6 divided by tangent 14 degrees. I'm going to key it in as a fraction. So 6 over tan 14. Rounding to nearest tenth, 24.1. Next, we want to find c, lowercase c, our hypotenuse, right? Using the trig function. Yes, I know we could use Pythagorean theorem because we now know the two legs, but let's practice using our trig functions. Going back to what we were given, the side length of 6, that's the side opposite our angle, and we're trying to find the hypotenuse. Opposite hypotenuse, that's sine. We're taking the sine of 14 degrees is equal to, opposite is 6, hypotenuse is c. Do the same thing if I cross multiply. We have c times sine 14 equals 6. Divide by sine 14, both sides, not showing that step. C equals 6 divided by sine 14. Go to the calculator. I already have 6 divided by tan 14. Let's see if I can just go back in and change tangent to sine. 24.8. So our hypotenuse length is 24.8. And, well, does it make sense? Is it reasonable? Well, definitely the hypotenuse does need to be the longest side of our right triangle, which it is. And this is a very small angle of 14 degrees. The side length opposite that was 6. Measure of angle B was 76, which is much greater than 14 degrees. So the side length opposite that is 24.1. So it certainly does seem reasonable. Okay, next we're doing number 16. Angle A is 57 degrees, and lowercase b, the side opposite angle B, is 12. All right, so angle A is 57 degrees, and lowercase b is 12. Now, in relation to the 57-degree angle, lowercase a is the side opposite, 12 is the side adjacent, and c is the hypotenuse. If angle A is 57 degrees, then angle B is equal to 90 minus 57, which is 33 degrees. Next, again, I'm just going to go alphabetical. I want to find lowercase a, right? Lowercase a. A represents the side opposite, and what do we have? We have the side adjacent. So opposite and adjacent, that is tangent again. So we say that the tangent of angle A of 57 degrees is equal to opposite over adjacent. The length of our side of adjacent is 12. Again, if I express this as a proportion, cross multiply, we have 12 times tangent 57 degrees is equal to A. Nice, our variable is all by itself. We don't have to do any dividing. We just go right to the calculator. 12 times tan 57. 18.5. Next, finding lowercase c, the hypotenuse. Again, going back to what I started with, and that was the side length of 12. So adjacent hypotenuse is cosine. So the cosine of 57-degree angle is equal to adjacent, length is 12, and hypotenuse is represented by lowercase c. Put cosine 57 over 1, cross multiply, and we have c times cosine 57 is equal to 12. We need to get c by itself, so we divide by cosine 57 both sides. So c is equal to 12 divided by cosine 57 degrees. .0. So our hypotenuse is 22.0, which is the longest side, right? 22.0, 18.5, and 12. Okay, and our last one, number 17. Here they give us that angle B is 32 degrees, and the hypotenuse, lowercase c, is 20.4. So on our triangle here, again, this is our hypotenuse. In relation to the 32-degree angle, right, lowercase b represents the length of the side opposite the angle. And again, in relation to our 32-degree angle, lowercase a represents the side adjacent to that angle. First, I'll find angle A. That's the complement of angle B, so that would be 90 minus 32, which is 58 degrees. Right? Now, we know what the hypotenuse. Again, I'm just figuring this out alphabetically first. So I'm going to find lowercase a first. A represents the adjacent side, so adjacent hypotenuse, that's cosine. So the cosine of our angle of 32 degrees is equal to adjacent over hypotenuse, A over 20.4. Write cosine 32 over 1, cross multiply, and we have A is equal to 20.4 times cosine 32. Key it into the calculator. $17.3. And now finding lowercase b. Lowercase b represents the side opposite the angle, and we have the hypotenuse that was given to us. So opposite hypotenuse is sine. So the sine of 32 degrees is equal to lowercase b over the hypotenuse 20.4. Again, write sine 32 over 1, cross multiply, b is equal to 20.4 times sine 32 degrees. 10.8. Again, just check, is it reasonable? Right? A was 17.3 and B now 10.8. And the hypotenuse 20.4 is definitely the longest side. It checks, seems to be reasonable. Another way of checking is you can certainly take 17.3 squared plus 10.8 squared. Is it approximately equivalent to 20.4 squared? It's not going to be exact because we have rounding involved. Okay, so this concludes tonight's video. Thank you.